Okay, so what if we know V naught, VF, and A bar, our average acceleration? Well, let's just mark what we know on the picture. We got V naught, we got VF, and we got our A bar. Incidentally, we don't have to write that as A bar. If V versus T is linear, it's just plain old A. But I kind of reinforce the idea that it comes from the definition of the rate of change and write it as A bar, even though it could just be written as A. Okay, well, if we know this, this, and this, how can we put these things together? What can we put these things together and get? Well, we can see from this map that if we know V naught and VF, we're going to be able to get delta V. So V naught and VF give us delta V. And you can think through how you would get delta V. I'll kind of write these relationships down, but right now we just see, and eventually we know that with V naught and VF we can get delta V. We don't need this diagram once we've mastered the reasoning, once we've solved a number of problems, but the diagram can be very helpful in learning to think through these relationships. Okay, so if we got this and this, what can we do? Well, we can find delta V. So now, okay, now we know all the things that are circled in red. What else can we find? Well, we know A bar and delta V, and we know that those go in a triangle with delta T, and we can see that distorted triangle right here in green, so that A bar and delta V will give us delta T. So now we know delta T. Well, we're closing in on the only two things we don't know, delta S and V bar. Okay, so what can we get now? If we know all the quantities in red, what can we do? Well, we know delta T, but that doesn't suffice to get V bar and delta S. There are too many things we don't know here. But, and we've completed the green triangle, the triangle for A bar, delta V, and delta T. That leaves us a triangle for V bar, V naught, and VF. Well, we've got two of the quantities in that triangle, so we know we're going to be able to find the third. And now we can combine delta T and, I'm going to write delta S, that's what we're trying to find, delta T and V bar to get our final quantity, delta S. Badly written S. Okay? So now we've completed the puzzle. Okay, now what are our relationships? Well, what's our relationship for V naught, VF, and delta V? Well, that's very simple. Delta V equals VF minus V naught, because delta V is the change in velocity. So if we know V naught and VF, we just subtract them to get delta V. But what about A bar and delta V? How do we get delta T? Well, remember that involved a little bit of a solution, but we could start with the idea that A bar is delta V divided by delta T. So that delta V is A bar multiplied by delta T, and delta T is then delta V divided by A bar. So we're going to be able to use that relationship, or just our intuitive understanding, because we can use our intuitive understanding once we get really firmly entrenched in the entire reasoning process from our definitions. Okay, well, then delta T and V bar gives us delta S how? Well, delta S equals V bar delta T. That one's pretty intuitive, but again, we want to be sure to connect it to our intuition. So if I'd given you quantities for V naught, VF, and A bar, this is the sequence of steps you would take to reason out those quantities. Now, as we will see, it turns out that if you know 3 of the 5 quantities, delta S, delta T, A, V naught, and VF, then you can always find the values of the rest. And there are actually 10 possible combinations of three of these 5 quantities, delta S, delta T, A, delta S, delta T, V naught, delta S, delta T, VF, delta T, A, V naught, etc. In 8 of those 10 cases, you can just do everything by the simple relationships that are involved in this picture. But there are 2 cases. The case where you know V naught, A, and delta S, and the case where you know VF, A, and delta S, that are more complicated. And we have to do a little bit more work to figure those out. But in most cases, if you know 3 of these 5 quantities in 8 of the 10 possible cases, all you need to do is understand the definition of average velocity, the definition of average acceleration, which is here in this triangle, and the relationship between V naught, VF, and V bar. Using this as a guide for practice, you can then very quickly reason out all the other quantities. In the other case, we're going to need some formulas, and they're formulas that you're probably going to end up memorizing rather than completely understanding, although they're not out of reach. They're not that complicated to derive. But at some point, you do have to start relying on some formulas.